Hey guys, this is 5.7, factoring by special products. And basically, we are practicing some shortcuts for factoring. Product means multiply. So we're going to start with perfect square trinomials. Tri means 3, right? A trinomial that is the square of a binomial is called a perfect square trinomial. So if I have a squared plus 2ab plus b squared, I can rewrite that as a plus b squared. If I have a squared minus 2ab plus b squared, I can rewrite that as a minus b squared. Okay. What we need to know about this is that the first term and last term are both a number squared. The middle term is either 2 times the square root of that first term and the square root of the last term, or -2 times the square root of a and the square root of b. Sorry, the square root of the first term and the square root of the last term. We saw this in 5.4 when we practiced multiplying polynomials, and now we're just going backwards with them. We're factoring them, okay? When you look at them, you are trying to determine, is this a perfect square trinomial? Okay, I'm going to give you an example. X squared plus 10x plus 25, okay? So here, what is the square root of x squared? The square root of x squared is x, so a is x. Okay, let's jump to our last term, b. What is the square root of 25? The square root of 25 would be 5, right? So my a is x, my b is 5. My middle term must then be, because it's a plus, 2 times a times b. So if this is a perfect square trinomial, we need to say 2 times x times 5. 2 times 5 is 10x. So it is a perfect square trinomial, okay? And my a is x and my b is 5. So I can rewrite that as x plus 5 quantity squared. Because this was a perfect square, this was a perfect square, and the middle term was 2 times the square root of that and the square root of that. All right. Now I'll give you 3x squared. No, I'm sorry. That will never work. I need that to be a 9. 9x squared minus 12x plus 4. Okay. If it is a perfect square, a will be the square root of 9 is 3. The square root of x squared is x. B, the square root of 4 is 2, right? So negative, because this is a negative example, negative 2ab must equal negative 12x. So we have 2 times 3x times 2. 3x times 2 becomes 12x. Sorry, and it was a -2. So that one is okay. So because we know a and b, and we know the middle is a times b times -2, we can say that this one is the quantity 3x minus 2 squared. Okay. Notice that for these, the last term is always positive. Okay. If the middle term is a minus, or if my second term is negative, it will factor with a minus sign. Okay. Let's look at example 1. X squared plus 12x plus 36. Okay, so A for this guy, if it is true, A will be x, right? Because the square root of x squared is x. B will be 6 because the square root of 36 is 6. Okay, and then positive, so 2AB will be 2 times 6 times x, which does equal 12x. So this one is okay. So A is x, B is 6, and we're changing it to A plus B quantity squared. That's the same. A plus B quantity squared. Okay. Here, this one's a mistake. I'm going to change this to the number 1, and I'm going to take out that y. Okay, just to make this easier, more usable, better example. Okay. So for this one, A would be 4x, right? Because 4 times 4 is 16, x times x is x squared. B would be B, we just leave at 1 because the square root of 1 is 1. 1 squared is 1. Okay. Negative 2AB would give me negative 2 times 4x times 1, which does give me negative 8x. That's nice. Okay, so we know that those work. That gives me a perfect square of 4x. This is the perfect square of 1. And then if I multiply 1 times 4x times negative 2, I get negative 8x. Okay, so that means I can rewrite it as A minus B. I can't say that without drawing the letter B. A minus B quantity squared. Okay, let's look at this one. Here, A would be 5x, right? B would be 3. 5x squared is 25x squared. 3 squared is 9. So positive 2AB is 2 times 5x times 3. Does that equal 50? That does not equal 50. 2 times 5 is 10x times 3 is 30x. So this is not a perfect square trinomial. We just have to do it the normal way, the way we practiced last lecture. Okay, so that is look for a common denominator, or sorry, a greatest common factor. If there isn't one, multiply A times C, and then find something that you can multiply to get that number and add to get 50. Okay, so we're going back to that real quick because this is not the correct format. So 25 times 9 becomes 225. Okay, so it should multiply to get that, and we should add to get 50. I'm going to tell you what the factors of 225 are, okay? The 225, they're both positive, so we're just looking at positive factors. You can have 3 and 75. You could have 5 and 45. You can have 9 and 25, like this one, or You could have 15 and 15. Do any of those look like they would add to 50? 45 and 5, right? So instead of 50x, I'm going to rewrite it. I'm going to leave A and B the same. Sorry, A and C the same. But I'm going to split B up. Any common factors between 25, 5, 45, and 9? There is not, right? So I'm going to factor by grouping. I'm going to make 2 groups. Here's my first group, 25x squared and 5x. I can divide them both by 5, right? And I can divide them both by x. 25x squared divided by 5x gives me 5x. 5x divided by 5x gives me 1. So there's my first half. Second half is a positive, so I'll put a plus right now. 45x and 9. You could divide them by both by 9, right? 45x divided by 9 is 5x. 9 divided by 9 is 1. So our common factor here is 5x plus 1. And we're going to multiply it by, so no sign in between, 5x plus 9. Okay, so that wasn't a perfect square trinomial like these two. Perfect square just means x plus 6 times x plus 6, 4x minus 1 times 4x minus 1. These were a little bit different, but we still found them via factoring. So this is just a faster way to factor if you have the right perfect squares. Our last example for perfect square trinomials is 16x squared minus 8xy plus y squared. So it's just like this one, except the y is squared, so it will actually work. A is the same, 4x. B now, you can see it's just y, right? Because y squared, the square root of y squared is y. And so negative 2ab should be negative 2 times 4x times y, and that will give me negative 8xy. Excellent. So this will work. So we just say it is a minus b squared, which is 4x minus y quantity squared. Next shortcut is called the difference of two squares. It factors into a sum. Sum is add, and difference. Difference is subtract. So basically, the difference of two squares needs subtraction and two perfect squares. Needs the minus sign and two perfect squares. And then we turn it into a plus sign and a minus sign. We identify the a and the b. We write it as a plus b times a minus b, or a minus b times a plus b. The order does not matter. Okay, so let's practice this one. And I'll write it at the top of this slide just so that we can look at it. All right, so for this one, a is x, b is 3, right? And we don't need to say that b is minus or a negative 3 because the negative is part of the equation. Okay, so a squared minus b squared is x squared minus 9. A is x, b is 3, so we change it to a plus b times a minus b. X plus 3 times x minus 3. Okay. 4x squared minus 1. A is 2x, right? Because 2x times 2x would give me 4x squared. B is 1, because 1 times 1 will give me 1. So now I just say a plus b times a minus b. Two x minus 1, 2x plus 1. Okay. This one has a fraction, but a fraction is a perfect square if both the numerator and the denominator are perfect squares as well. Okay, so let's find the perfect square of 16 over 25. The perfect square of 16 is just 4. The square of 25 is 5. So 16 over 25, if we put it under a radical, we'll come out with 4/5. Okay, so A is just y, and B is 4/5. So we write that as y minus 4/5 times y plus 4/5, because it does not matter whether the plus is first or the minus is first. It's multiplication. Will not affect it. Here we have 36a squared. The square root of 36 is 6. The square root of a squared is a. B, we have 49b squared. The square root of 49 is 7. The square root of b squared is b. So I have 6a minus 7b times 6a plus 7b. 4x to the third minus 49x. Uh-oh. This is not a perfect square, and this is not a perfect square, but you see that there is a greatest common factor that we can pull out. If we pull out that factor, we might get some perfect squares. That factor is x. So 4x to the third divided by x gives me 4x squared. That's a perfect square. 49x divided by x gives me 49. That's a perfect square too. So now we have a is 2x, b is 7, right? And then we have x on the outside. So I'll leave x on the outside, 2x plus 7, 2x minus 7, okay? Here, a is 7, b is x, so we say 7 plus x, 7 minus x. And I'm flipping these around just so that you are reminded that it does not matter the order, okay? X plus 1 squared minus 9. X plus 1 squared, the square root is x plus 1. So the biggest challenge here is getting the right parentheses. X plus 1 plus 3, right? Sorry, I kind of jumped ahead. The a is x plus 1, and b is the square root of 9, which is 3, times x plus 1 minus 3. Yeah. I'll give you one more example. Negative 72 x squared plus 2. This doesn't even have a minus between them. 2 isn't a perfect square, and 72 isn't a perfect square, right? What am I doing? Is there any greatest common factor that I can factor out of this? Yes, there is. The greatest common factor I can factor out of this is a -2. So if I take out a -2, -72 x squared divided by -2 gives me 36, positive 36 x squared. Positive 2 divided by -2 gives me a -1. Now I have some perfect squares where a is 6x and b is 1, right? So now I can say -2 times 6x minus 1 times 6x plus 1. So you might have to factor something out before you start using one of these so that you can use it, just so you know. Now we have the sum or the difference of two cubes. There are mistakes. There are mistakes on this page. So please change this guy to a to the third minus b to the third. This is okay, but this should be a plus. The first term, okay, so we have a cubed, sum or difference of two cubes. Sum is add, difference is subtract. So two cubes, cube just means to the power of 3. A to the third plus b to the third, we can rewrite as a plus b times the quantity a squared minus ab plus b squared. If they are subtracted, a to the third minus b to the third, I can rewrite it as a minus b times the quantity a squared plus ab plus b squared, okay? So for example, factor x to the third plus 1. The first term, x to the third, is the cube of x. The second term, 1, is the cube of 1. So we're going to say a is x, b is 1. Okay. The sum of two cubes, because it's addition, right? The sum of two cubes, a plus b, sorry, a cubed plus b cubed, factors as a plus b times a squared minus a times b plus b squared. Okay, so x to the third plus 1 becomes x plus 1 times x squared minus 1x plus 1 squared. And I'll just simplify that just a little bit. So that becomes x plus 1 times x squared minus 1 plus, or sorry, minus x plus 1. Let's rewrite it one more time. I just made a giant asterisk on there. X plus 1 times x squared minus x plus 1. Final answer. Okay. Let's practice this for example 4. That was a book. So remember, a cubed plus b cubed becomes a plus b times the quantity a squared minus a times b plus b squared. But a cubed minus b cubed becomes a minus b times the quantity a cubed plus a times b plus b cubed. Okay, so this one was minus. So we're going to be using this if it is two cubes. The cubed root of y to the third is y. So we're going to say a is y. The cubed root of 64 is 4, because 4 to the third is 64, or 4 times 4 times 4 is 64, right? So A is y, B is 4. So this becomes y to the third minus 4 to the third, right? So that factors to y plus, sorry, y minus, that factors to y minus 4 times the quantity y squared plus 4 times y plus 4 squared. I'll rewrite it one more time. Y minus 4 times y squared plus 4y, and I'm just going to call this 16 so that it's simplified, okay? (64) y to the third plus 1. So it will be this if it's anything. A is 4y, B is 1, right? So we have 4y cubed plus 1 cubed. That factors to this one. 4y plus 1 times the quantity, 4y squared minus 4y times 1 plus 1 squared. Just going to make it a little bit simpler. 4y plus 1 times the quantity. 4 squared is 16. Y squared is y squared. Minus 4y, I can leave off the 1, plus 1 squared is 1. Okay. 4y plus 1 times the quantity 16y squared minus 4y plus 1. Just one more example that shows the factoring technique, okay? If my math lab gave you 64 y squared minus x to the third y squared, could you say that those are perfect cubes? You could factor something out, right? So I can factor out y squared, and then it becomes 64 minus x to the third. I don't know why in all 3 of my examples I use 64. 64 means that a is 4. X cubed means b is x, right? So now I have y cubed times, this is the minus. So a cubed minus b cubed becomes a minus b, 4 minus x, times 4 squared plus 4 times x plus x squared. Just rewrite it one time. So that becomes y squared times 4 minus x times 16 plus 4x plus x squared. All right, so those are just faster ways to factor polynomials once you can identify cubes and squares. Thank you guys so much. Well done today, and see you next time.